welcome to the live coding session in C language. Today I will be implementing queue data structure in C. Let us start with that. First, just create the header file. This library provides the functions to allocate and free the memory. So this is what we are. This is why we are including this library. And next is std bool.h. We get bool and true and false keywords to be used in our functions, and we can safely use it in place of 0 and 1, and we can use it in if statements. So next we are going to create a structure, struct queue. The queue needs that in queue data comes from behind and goes from the front. So data comes from the end of the queue and goes from the front of the queue. If data came from the front of the queue and was removed from the front of the queue, then it will be called a stack. It won't be queue. So in queue it is first in and first out. If the data which comes first is the one that goes out first or gets processed first. So what are we going to need? So we are going to need I need to include it provides multiple unsigned integer types, and that we can use in our code. So this is going to be our front index. This is our rear index. Then we are going to have the capacity, max capacity. And then we are going to have a data storage data. I should use a pointer or I should use an array. Today I learned a different way to allocate memory for structures. I think I should use that. If that doesn't work, then I will be using this pointer type. So I'm going to use an array to allocate this memory, to define the data holder section, and it is done. Next is create stack, or basically allocate memory for a stack. So it is going to be external, because we are just declaring it here we are not defining it, and definition is going to be in different file. External struct queue star stack is going to take capacity maximum. I'm going to return a pointer to a memory allocated for a stack structure. that is done. And next we're going to do is free memory or delete stack from memory, and that is done. So extern struct, nope, we are going to use void because we are not going to return anything. Delete queue is going to take a struct queue star queue create queue and delete queue. Next I'm going to create a file that is going to use this header file. It is going to be going to include stack.h, and with this inclusion all the header files that we have declared at the top is going to come. So first thing we are going to implement is the create queue function. This function struct queue create queue into capacity. And we are going to return struct queue star memory allocation of size of struct queue plus size of integer multiplied by capacity. So this is the size. This size function will allocate memory for top three variables: front index, rear index, maximum capacity. Because the fourth part is an array, we haven't provided any size for it, so compiler doesn't know, or system doesn't know that how much memory should be provided. So it just provides the memory for 3 block. Then we get the memory of the size of an integer, and multiplied by the capacity, number of integer that we are going to store in this data array, and we use that. So queue is going to be queue is going to be this part, and it is correct. We are allocating the size of a queue, a stack struct queue, size of a structure of queue, and getting the size of integer and multiplying the by the capacity, the number of integers that we are going to store to provide the size of for this data variable. And I'm also going to check that if queue is equal to null, printf the memory allocation and it is done. The reason I am using this array in place of the pointer is that this entire memory will be assigned in one block. In the pointer, the first three variables, the front index, rear index, and maximum capacity, is going to be allocated in one block, and that pointer will next pointer, that pointer will point to a different memory block in the memory where the real array is stored, and we will be storing value in that location. So that is going to be slower than this. And basically we can say use this to print the value, print a log that the memory location has failed, but we are not going to do that. I will use this to assign values, because in the cases where memory you cannot allocate memory, your system is running out of memory, then it is better that your application crashes and everything is cleared. Because if you cannot allocate any memory, you won't be able to work, and there may be system where they catch these issues and try to use to free whatever the memory they already have and use that, but that is not going to happen in this case. So what I'm going to do, front index is going to be Q, rear index, because they are not pointing at any point in the array, so this is what its value going to be. And next, max capacity and data. And next is Queue capacity is going to be value stored in this variable at this memory location. And we can run over the loop and try to clear all the values in the memory assigned by the for the data array, but we are not going to do that because we are going to override that value anyway, so I'm going to leave that part. So this we have initialized the array, and creation is done. Delete queue. Then I'm going to delete the queue. So if queue is null, we can check for this that queue is null, then just return, else we can use a macro to do this work, but I prefer functions over macro. Macros are not that readable, I don't like them. Delete queue is done, and next is status check functions. For example, boolean is full q star or external boolean is empty struct q star, and isQueueFull and isQueueEmpty, and both of them takes the queue as the input and returns a boolean value true or false to signify that, to tell that the queue is full or not. If queue is full, we cannot put any more data in it. If queue is empty, we cannot take any data out of it. So it is this is a needed function needed for to do our work. Boolean is it is not bool, it is bool, is queue full. It's queue full. Give me the structure, and I will tell you that if queue is full or not. If queue is equal to null, what should we return over here? It is true or false. Return true, so that user shouldn't put any value in it. That condition should fail, and otherwise we are going to see that return queue I'm going to declare a fourth variable, current current count of items. So going to move to line number 10 and add other value queue equal to 0, and so should check that if current count of items equal to queue max capacity, then the queue is full. And so we can add the web condition below and say that if queue is null or current count of items is equal to current maximum capacity, then queue is full. Again, we can do it as a macro, but I like to do it as a function because it is better, it is more readable. Is queue empty. Let me do some calculations. I'm trying to see that if I can get rid of this maximum capacity, the current count of items variable, then I will remove that. Okay, I think we can just write a function and get rid of this variable, and we are going to remove that variable. I don't want to waste any memory, and it's going to say that extern bool say that number of items Q. We'll take a struct Q star Q, or I will just say constant front index constant list 8 t pointer so go over here and so what is going to happen if index is equal to rear index 1 if return 0 return 1 if index is less than a rear index, then in that case we need to have the maximum capacity of the array. So to have that, I will be removing all of this, and I need the complete queue. I think they should work, but it didn't work. So struct queue number of items in queue, and so coming over here back to here. UE, and then what are we going to return? We are going to return we're going to return queue minus rear index minus subtract queue front index, add 1 to it. I have put everything in the bracket so there is no confusion about this operator precedence and everything. So that is done, and I will try to also write this code. I will try to modify this code so that we won't have this many if statements or branches. And next is a case where if we are here, that means that when front index then greater than rear index, in that case what's gonna happen? Queue max capacity from this number. We are going to subtract the current front index to get the number of value between the current position till the end of the array, and we are going to add queue rear index plus 1, because rear index is suppose 1, so the index is 1 but it is on the element number second from the beginning, because and the array starts from 0. So this is the cases where this is the case that we are handling, that if it is at index 1, then it is at the number at the data number 2 or integer number 2 or memory location number 2 in the array. That is that because of that we are adding this 1 return. Can we remove these if statements? We can remove this. If indices are less than equal to queue rear index, so if both the front and rear indexes are at the same position, suppose that at index number 3, so 3 minus 3 is 0 and plus 1, that gives us 1. That means that we have one element, and which is correct for the cases where both the front and rear are pointing at the same point in the array. So that is done. Then we can get rid of this and called number of items in queue. Queue is equal to this, then queue is full. If stack is equal to keep writing a stack null or front index is less than 0, then our queue is empty. Or we can say the rear index is less than 0, then our queue is empty. So we have implemented functions to create a queue, delete a queue, to find the number of items in the queue at the current time, and we have function to check that queue is full or not, or it is empty. Next is our functions modifications, data modifications functions. And void add, I say put and remove, I will say that. So a struct integer star data int remove struct One of the problem that we are going to face here is that what kind of data are we going to return. So I will be returning end of file when there is nothing to where the stack is empty. Say I will do with the put function where I will return end of file, signify that a stack is full and cannot be allocated any, and we cannot add any more value to it. So that is done. Put and remove int put data, it is going to then return end of file. And next we have if is full or if is queue full, turn end of file. Now we have to put data in this queue. So I have to check that is this the first element that we are adding. If front index is less than 0, if it is, then we have to do queue front index and is equal to queue rear index is equal to 0, and we are going to put value and say that queue data at the rear index and data, that is put. I have put the data over there. So this is one part. Next part is else. We have to check that else the what is going to happen, that queue rear index is going to be something like if the queue is already at the 5th index, suppose our array is of length 6 and the rear index is already at 5th position, so next we increment it, we go to 6, which is the out of the bound of this array. We are trying to access a memory that we do not own, our application is not allocated, is not permitted to access. So at that point we will have to rotate that index to show that we can still have the value, so that we can get a proper index to put our value. and Q is equal to rear index, and Q is if Q index plus 1, or I can move this to over here and say Q increment the rear index, and then front index is going to be rear index. So if it is -1, then it is going to be 0, so our issue, we do not need to verify it anymore. And next is we will have to verify the value that Q rear index, else if rear index is equal to Q is equal to maximum capacity, that we have the length is maximum 6 and the rear index is 6, then it is equal to maximum capacity. In that case we need to rotate that array, and I will say the Q rear index is equal to, and 0. Is Q full? Okay, so this is how we will have to handle these indices to create a circular array. Q front index, Q rear index. Okay, next we are going to int, or we have written some value return we're going to remove a value from this Q if Q is null. I think null check already happening in isQueueFull and isQueueEmpty, so we do not need to do a null check again. If is isQueueEmpty, return end of file. Otherwise, if it is not empty, and in that case we are going to have the data. In that case we are going to return the data present over the front index. So in data is equal to Q front index, and we have removed this data, so index is I have incremented. I need to increment it, and So if queue the front, we are removing data from index number 1, so next it is front index is going to point to the next index 2, because we have removed the data from queue from index number 1. So it is done. So after I have incremented it, I will have to check that if queue is equal to queue rear index, I mean that this is the last element and we have removed that, then queue front index is equal to queue is equal to -1. Queue front index is equal to queue rear index, and we have put it as a -1. And next we are going to check that if else if queue index +1 is queue is equal to number is equal to queue maximum capacity, then queue front index is equal to 0. Same over like we did it over here, but in this case we are inserting a value, so we already incremented the index and then we checked for the that it satisfies it is the correct index or not, then we modified it. In this case we need to check a special case where we need to check that this value is the last value, it was the last element and we have removed it. Now queue is empty, so I have reset all the front index and rear index to -1. This is a different case and we are handling that, and return data. And why we are not returning a pointer from here, because by the time this function will return, it is possible that this stack memory address won't be there, and it is not anyway stack memory address, this is coming from this array, so it is going to be there, we can use that. Still this part is done, we have created all the required functions and it is time for us to run and check this check our code. So I'm going to compile it for the first time, gcc by mistake I named the header file as stack.h, and I'm going to remove that. QC line number 18. Error expected curly brace left before void external struct void delete queue. Okay, it is in header file. This is not a structure. We are not returning any structure from it. Conflicting types for remove extern int remove. And why is that? Returning int in both the cases. Okay, it is it is confusing it with some library function defined in some header file that I have included from the standard C library. Put in. Okay. Compiled successfully. Let us test this use of this these functions. First, I'm going to create a stack. Again a stack. I'm going to create a queue. Of size 4. So that I can have these methods right in front of me, so that I can see that what variables values I need to pass. So queue is ready, and next I'm going to say that if queue is not equal to null, print queue created. And delete queue and passing argument 1 of create queue max pointer of integer without a cast. Okay, it is asking for a memory address, so I'm going to give it a memory address. queue created, so it has worked. Now I'm going to make some insertions and deletions, and going to queue, put in queue and print f and number of items So our real test is now that will this the data implementation of array type is going to work or not. So let me run it. Number of items in queue is 6, so this function implementation is not working. My back hurts. Let me check the value before we put any value in it. Number of items in queue is 1, whereas there is no item in it. It is just empty. Why it is 1? It should return 0 because I have put the front index and rear index as -1, so it should be returning 0 to me. Or I think that the issue is with the this data type. If I fix this, it should work now. Number of items in queue is 1. No, it's not. It is 0. So what is the I'm going to create a function void print indices. What? Oh, I got it. The issue. What is the issue? Is I got the issue. This is overflow issue. This is what is happening. The -1 is converted into is converted in value 255. Why it is not happening? This is what issue is, that int underscore list 8 underscore t stands for unsigned car, and that is overflowing to 255. That is the issue. So I have to cast this -1 into a value that can be put inside this unsigned car value. Okay, I got this. I got the issue. This is an unsigned int by design. So my mistake is I am putting a signed value. I am putting a -1, and -1 is 255 if it is unsigned. Now it should work without any issue. -1. It is working now. So it was my mistake that I was using unsigned value to store unsigned character, unsigned integer to store a negative value, and it is done, and I have put the value in queue, and next I'm going to do it multiple times. Okay. And let me call a function to print the entire stack. First, entire queue. Return is isQueueEmpty, then return, otherwise int then it is going to be two type of implementations. One, when if q is less than rear index, then front index, rear index. So int index is equal to, and while is less than rear index, print versatile d space data and index plus plus and end, join and remove print it. One is this, and next is case where else if Q front index is greater than Q rear index, when after deleting multiple insertion, the rear index are rotated and circled to the front of the array. So in that case, this is the code duplication, we can remove it, but I think it is okay for now. In that index, where we will be printing multiple data, and what one case index is going to start from, and it is not going to be the rear index, it is going to be capacity and so we have printed data from start front to the end of the array. Then we will have to start from the 0th index to the index till the rear index points, rear index of this queue exists or points to. So index start is going to be 0, and next index end index is going to be rear index, and while and next case is else next case is when front and rear index are at the same point. In that case we will just print the print central D and index and replace print with print f no, yes, 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 no. And I will print a new line after that to add line break. So print stack should work now. This function should be working, and after adding so many, I will print queue let's check it is compiling or not. 71. It should be like not less than, this should be equal to, and (14, 11, 12, 13). So we have added the values in same sequence, 11, 14, 12, 13. We have the values in same sequence, and we had number of items 4, which is correct. I'm going to remove something from them, and then we are going to print it again. Then I'm going to print print queue remove from queue didn't work. Why didn't work? It should have worked, and I'm going to check that. So remove from queue is not working, and we are going to check why it is not working. Okay. Queue. I didn't cover this condition that if it is normal case, then I have to decrement the size of, I have to increment the size of queue front index, not. It is moving forward. All the indexes are moving forward and going circular on that array. So now it is removed, and the correct number of items are there. When we are able to see that. So it is queue is working, and with this session, the creation of queue is complete. The creation of queue data structure, and I have implemented right in front of you, and I have made many mistakes, and I have corrected it right in front of you. So I think you understood. You understand now that how queue works, and how the errors that I faced, or you are going to face, or you are going to correct it. So with that, this coding session ends, and thank you for watching.